In this video, we're going to write a Cartesian equation in polar form. And they give us 3x squared minus 3y squared equals x plus 3y. Now, one thing we need to know is that we want this to end up with thetas, and we want r and theta in this equation instead of x and y. So we're going to go back and use this. We know that theta, we know that x is equal to r cosine theta based on our previous work. And we also know that y is equal to r sine theta. So I'm going to use these two expressions and plug that into this equation. So I end up with 3r cosine theta squared minus 3r sine theta squared is equal to r cosine theta plus 3r sine theta. Now we're going to square some stuff. So we end up with 3r squared cosine squared theta minus 3r squared sine squared theta equals r cosine theta plus 3r sine theta. So what I want to do is I want to rearrange this so that I can get this into something useful. So I'm going to factor out 3r squared here, and I get 3r squared, and then I get cosine squared theta minus sine squared theta is equal to r cosine theta plus 3r sine theta. And then I'm going to look and I'm going to say, okay, I know that cosine squared theta minus sine squared theta is actually equal to a double angle formula. That's cosine 2 theta is equal to cosine squared theta minus sine squared theta. So I can do the substitution here for cosine 2 theta. So I get 3r squared cosine 2 theta is equal to r cosine theta plus 3r sine theta. And then I want to, let's see, I'm going to factor out an r. Actually, I'm going to divide an r out. I can divide an r out of each piece. So I'm going to divide each piece by r. And I get 3r cosine 2 theta is equal to cosine theta plus 3 sine theta. And they've solved all these equations for r, so I want to divide here by 3 cosine 2 theta. And I end up with r equals cosine theta plus 3 sine theta all over 3 cosine 2 theta, which is the top selection here. So that substitution right there, where we did the double angle formula, that kind of helped us simplify this down pretty well.